Hi everyone, I'm from SK Engineering Limited. Welcome to this demonstration of the Spectrum Pipelines suite of software. Spectrum Pipelines is a set of modules of design and integrity calculations for onshore and subsea pipelines. The software suite comprises 13 different modules, and each module is dedicated to different aspects of pipeline design. Today, I would like to give you a tour of the Upheaval Buckling module, which is used for upheaval buckling assessment of subsea pipelines in accordance with DNV-GL RP F110. The module is activated by double-clicking the application file, which loads all of the software features. The graphic user interface has a very simple and user-friendly layout, which assists users with entering the input data on screen. The user interface is divided into 3 screens. The pipeline and coating data is entered in the first screen. This includes pipe material properties, such as the material density, Young's modulus of elasticity, the coefficient of thermal expansion, and Poisson's ratio. Concrete coating parameters such as concrete density and concrete coating thickness are also entered. Process parameters are then entered. These include the pipeline internal pressure, the reference height at which the pressure is measured, fluid temperature, and the water depth at which upheaval buckling needs to be calculated. The ambient seawater temperature, seawater density, safety class, and residual lay tension also need to be inserted. We then enter the geotechnical inputs, such as soil type, which could either be sand or clay, the uplift resistance factor for soil and rock, the submerged weight for soil and rock, the background soil backfill cover, and the DNV GL-RPF110 roughness factor. The user also needs to specify the clearance between the bottom of the pipe and bottom of the trench, the level of embedment of the pipe in the soil, the out of straightness height, the wavelength factor, the uplift resistance mobilization distance, the depth of slurry layer, if any, and the out of straightness survey standard deviation of measurement. The geotechnical inputs such as undrained shear strength and soil submerged weight for undrained global and local failure check continues on the second screen. Some additional input parameters such as empirical factors based on field tests, soil undrained shear strength below the pipe, and gap between the pipe and the soil in the trench are then entered. The third screen displays the results of the upheaval buckling assessment. First of all, the suitability of the soil for mitigating upheaval buckling is assessed, and the results presented. In the case where the soil alone is sufficient to mitigate upheaval buckling, the soil backfill cover height is presented. However, if soil alone is not sufficient to mitigate upheaval buckling, the additional required rock cover height on top of the soil background cover is presented. If the soil is not suitable for upheaval buckling mitigation, then the soil needs to be adducted out of the trench, and rock needs to be placed directly on top of the pipe. In such scenarios, some residual locally failed clay slurry may remain in the trench. The depth of the slurry layer is considered in the calculations for the required trench and rock cover height. The software also performs a downward resistance check. If there is a potential for soft foundation failure, the software recommends additional rock cover to be added to the base rock cover height, which was required to mitigate upheaval buckling. The result sheet, as well as a summary of the input parameters, can be saved as a PDF file. Each project case can be saved and reloaded for editing in the future. Thanks for watching this demonstration of the Spectrum Pipelines Upheaval Buckling module. For demonstration videos of other modules, please get in touch with us at info@engineeringsk.com or enquiries@z-subsea.com. Spectrum Pipelines, making pipeline design and integrity smarter.